Hi YouTube family, welcome back to the series Java Full Stack Made Easy. So let's get started with the second session. As we were talking about Java main method in the previous session, we'll continue. And at the end of the video, what I said was about the static and the non-static method. So as I told, what exactly these static and non-static methods are, we will be testing in this particular video. So first of all, I'll just remove all the comments and the unnecessary code which will not be required into this video. So I'll just clean up this everything, and I have an object reference first, and then I have a static method. So let us also create a non-static method and try calling a non-static method directly. So let's create a method called as display, and let's just write display function in this. Again, system.out.println, control space and enter. That's a magic of using an IDE. So let's just call it as display method. So when we call this, we will see whether an object reference is required or not. So for my main method, which is this, let's change the name for it as for now. So let's just call it as static function or my function. Okay, so I'll call it as my function so that you are not confused that with the main method. Okay, so let's just name it as my function. No argument to this. Let's just this be hello world my function. Okay, so that's what I'll make it, and let's remove the arguments as it does not take any parameter with it, and this is just the my function. So let's save that, and now let's try to call the display function without giving any object reference. So the moment I try to do this without giving any object reference, you will notice that I'm getting an error here. So the reason for that error is both these methods that I have created. Let's also remove public. Let's not make any method public, so that only difference between these two functions is static and non-static remains. So now my function can be called without any object reference, whereas display function cannot be called with an object reference. So this line would give you an error if you try calling it like this. Okay. So to resolve this particular error, what I have to do is I have to use the object reference, that is demo1, and then call the display function. Okay. So when I'm doing that, I'll be able to call this function, and if I run this, I'll get the result of both the functions. Hello world, this is my function, and the display function as well. So let's now see why non-static functions requires an object reference and why static functions does not require an object reference, and that is the same reason why main is made as static. So before we dive into the details of static and non-static, let me first put this code into the repository for your reference. So as in the previous session, I created this repository Java Full Stack Made Easy, and I created day one, and within that day one I have created more demos in it. So once again, I'll add up new files here, and let's name this repository as day 2. Okay, and then I'll put up this particular code into it. Okay, let's call it as day 2 slash demo 1 of day 2. So let's just hit commit, save changes, so that you see it into the repository now. So if you go to Java Full Stack Made Easy, you will see day 1, day 2. So when you go to day 2, you will see more demos added into day 2 later. As for now, just demo 1 is added in here. So let's go back to what we were talking about. So this error was basically because I was not using an object reference. Alright. So static functions, the reason for this, I'll write static functions does not require an object reference because they exist even before creation of object. Okay, static exists before object. Okay, so because static object exists before an object, they are independent of object. They does not depend on object. Now why they do not depend on object? Because static has its own memory. Now, and most of the Java developers do not talk about that, but in this video I will be showing you static having its own memory, right? Now how do I prove that static has its own memory, be it a static variable or a static function? I will also introduce variables to you in this particular video. So first of all, as we discussed, my function does not require an object reference and demo1.display requires an object reference. So when I say object is an instance of a class, and I'm saying that on this particular line of code, new demo1, an object is created, right? So yeah, on this line itself, there are two things that are happening. One is the reference variable created, another one is the object created. So this is this demo1 is just a reference variable holding a reference to the object created at the right hand side, that is new demo1. And whenever we use this new keyword, it indicates that we are allocating some memory to it. So when I am using this demo1, I am actually saying this display function does not contain its own memory, so get the memory from demo1 and execute. Okay, so when I am using my function, I did not require any memory from the object. So if I'm not borrowing the memory from the object, it means that I have memory reserved for statics available. That means memory is already reserved for static, be it a static function or a static variable. Let's take an example of the static and non-static variable also, and then again we will see whether the static and non-static variables require memories or not. Okay, so I hope that by this you at least have an idea that static has its own memory. Now again, about the detail about the memory being expensive, whether everything can be made static or object references are required, instance variables are required, methods to be created as static or non-static, will go in details. Okay, so as for now, I'll just clean up everything that I have written here, the static function, the non-static function and everything. Let us go ahead and talk about the variables in Java. Okay, so when creating a variable in Java, we can create variables of basically three types in Java. One is the local variable, okay, and then the instance variable, and then the class variable. Okay, so we can have local, instance and the class variable. So each type of variable we will see where it fits in and how do we make use of those variables, when to create what. Okay, so let us first talk about a local variable being created in Java, and once again I'll also talk about the types of data types in Java while we are talking about the types of variable, and also comparing the static and non-static variables. So it's a kind of series of things which we will be talking about, because definitely they are linked with each other. All right, so now let's create a simple local variable and see how what is a local variable and what are the characteristics of a local variable. So let me create a simple method. Once again, let's call it as void display. Now in my examples, I always use display xyz abc pqr, but that is not at all a good programming practice to name functions and variables like that. Always have meaningful names to your functions and to your variables. Like in my previous video, I told you, while creating the objects, Java says you that create an object which has same name as the class name, so that at any given point of time you can understand that that particular object belongs to that class. Like for example, if the object of class car is created as car itself, so even after 100 years you will be able to say that this object car is created for the class car, right? So in a distributed environment where you are developing application with the team, it will be very much necessary to provide meaningful names to your functions and variables. So do not just follow everything that I follow. I just follow that to make the code short and simple to explain. Okay, so now this display function will have a local variable. A local variable is one that is created inside the function. So I will be creating a local variable here, and let's call that local variable as test, and that is of type integer. So I am creating the local variable test, and let's give the integer value to it as 9. So now the moment I create a local variable and initialize the value to 9, you might see that there is a warning here. The warning says that I have not used that variable. So whenever you are creating local variables, it has to be basically used, else there is no point of creating those variables. Now why is that and all, again we'll see that. So first thing is, I'll just try and print that variable and see the result of it. System.out.println, I'll print test and see the result of this. And obviously to call to see the result of that, we have to call that particular function, since it is a non-static function. So let's call that function, save it and see the result of that variable. So you can see that the variable is printed as 9. Now what I will do is, I will remove the value that is initialized to this particular variable. So the moment I remove the value initialized to that particular variable, you will notice that there is an error on this. Okay, so now why is that error, or does Java allow us to separate the declaration and initialization of a variable? Now what do I mean by declaration and initialization of a variable? See, variables can be declared first and then they can be initialized, so which means something like this can be done. So this part is considered to be a declaration part and this part is considered to be a initialization part. Yes, Java allows us to separate declaration and initialization of variables. So here declaration and initialization of variable is separated, and once again we get the result. So which again means that local variables must be initialized before its use. So that is one more point about the local variables. Now let's just save it and run this again to see the result. So I run it again, I see the result. So which means that declaration and initialization can be separated, but as I told you, it has to be initialized before its use. Although in this line of code I'm initializing the variable, but still I'm getting an error because it has to be initialized before its use. Now why is that rule available? Why it has to be initialized before its use? And that rule is only for the local variable, it is not for the instance variable. Let's say let's create an instance variable and test that. Okay, so let's now bring this line below this, local variable initialized before its use, valid thing. Now let me create another variable int, and let's call it as inst var, considering it as an instance variable. So inst var is equal to, let's give the value as 10 here. Okay, and this is an instance variable. So what is an instance variable, we will talk about that later, but currently our focus is on the local variable. Okay, so just comparing the local variable and instance variable to tell you why the initialization has to be required before its use. Now instance variable, again I have declared it and initialized it. As we have seen, declaration and initialization can be separated. So let me save that and let's try to print that instance variable as well here. So let's just say instance variable, save it, run this and test whether we get the result or not. So here we are getting the result as 10. That's completely fine. So what I will do is, I will just try and remove the initialization part of it. The variable is just declared but it is not initialized. So if a local variable is just declared and not initialized, we were getting an error that local variable has to be initialized before its use, or local variable might not have been initialized. But for instance variable, even if I don't initialize it, I'm not getting an error. If I'm not getting an error, let's see what result we are going to get. So now when I run this piece of code, you can notice that I'm getting 0. So there are default values available for instance variable in Java. So because this variable is of type int, the default value is 0. So what does that mean? It means that local variables do not have default value. So that is why it has to be initialized before it's used. So if suppose I'm trying to do this, if I try to comment this out, it says that variable test might not have been initialized. So it's a compulsion. Local variable, while you are creating, you have to initialize it. Reason behind that is that local variables don't have any default value. So you can make point of these things which I am talking about. Local variables don't have the default values. Local variables must be initialized before its use. Okay, and instance variables do have default values in Java. The default values depends on the type of data type that is being used with the variable. Okay, so what I will do is I'll put this code as well into the repository. You can play along with this code. You try to give the value to this instance variable, try to remove the value to this variable, and then test the other characteristics of the variables. That will be fun for you. So let's go ahead and create more demos in this. Now I'll just put this into another file and we'll name it as demo2. Okay, and demo2 is about what? Local variables. That will be more meaningful name again. So let's just comment the changes, go back to the code and continue what we were talking about. So local about the local variables, we got to know that local variables must be initialized before it's used. Local variables don't have the default value. And then another important point about the local variable is that the local variables are accessible only within the functions where they are created. So let me create one more function and test it. And here I'm going to create one more function. I'll name it as ABC, and let's try to do sys out here once again. Control space, enter, and now I will try to print both these variables in this ABC function as well. Okay, so I'll just copy paste that. Let's save it, and the moment I save it, you can notice that instance variable which I'm calling has no error on it, but the test variable which I'm trying to call has an error on it. That is because test is a local variable and it cannot be used, it cannot be accessed outside the function display. So if I put my cursor on this error, it says test cannot be resolved to a variable, which means that my compiler is unable to understand what is this test because it is a local variable. So which means that local variables can only be accessed within the function where they are created. So these are the characteristics of a local variable. Local variables are also called as the temporary variables. Okay, or you can also call them as the stacked variables. Okay, so this cannot be accessed here. Local variables can only be called within the function where they are declared. So it cannot go outside the function, whereas this instance variable, they can travel outside the function. And let's just test it now. Instance variable, and let's give the function name here. I'll just say ABC plus the instance variable name in there, and I have to call ABC once again to see the result of that. So again, let's go for demo1 dot ABC. Let's save it, run it, and see the result. All good. So we created multiple functions here and try to call local variables and instance variables. Let's create another file and add this demo3 to it. Demo3, again, local versus instance variables. All right, so now as we are comparing the local variables, so we got to know a lot in fact about the local variables. Local variables don't have default values, must be initialized before its use, and can be accessed within the function where they are created. Okay, now that you got to know about the instance variables and the local variables a bit, we'll also talk about the class variables. But before talking about the class variable, let's talk about one more important point here. What is that? So instance variables can travel anywhere in the functions. A local variable, let us try and initialize it here itself, just to shorten the code. Okay, and now just a minute question for you is that, can my local variable be declared as static or not? So since we were comparing static and non-static stuff, so can a local variable be static? So whenever I declare a local variable as static, so now you might say that's fine, local variable cannot be declared as static because it is present inside a non-static. So what I will do is I will try and make it as static, and then once again I will test it whether I can create a local variable as static or not. Okay, illegal modifier for parameters. This can be one of your interview question, that whether a local variables can be marked as static or not. So it means it clearly says no, local variables cannot be marked as static. That is because your class variables itself are what? Static variables. So the static variables, they are loaded in the memory when the class is loaded. So local variables cannot be static. So do remember that point. Local variables cannot be static. And also in this example, I'm getting another error. The error is because of this function being static and it is trying to call a non-static variable. So our main agenda of this video was about the static and non-static variables, or static and non-static functions itself. So again, in these examples we will see how the static and non-static variables behave. So if I just remove this for now, it is completely fine to have a instance variable being called. Okay, and if at all I mark this method as static, I am unable to call the instance variable. So let's go ahead and create the third type of variable, that is the class variable, which is static variable, and compare the instance versus the class variable. Okay, so let me declare it as static. Stat var static variable is equal to, let's say, 100. Okay, it should be of type some data type, right? So let's give the data type as integer. We still did not talk about the data types available in Java. We will talk about that later. So as for now, we are just talking about it. That's why I always tell that my videos are targeting to the audience who are at least a bit aware about Java, okay, or at least C++. That will give you an added advantage. Now coming to this part wherein I created this display function and ABC. Now I have created a static int stat var and I am initializing that with 100. Let us try and see whether a static variable can be called inside this particular function or not. So let me just call the static var here, and in the next function as well. So since that variable is not declared within any function, it has to be called anywhere, right? So let's save it and let's test whether it can be called in both the function or not. So let's run it and you can notice that is being called inside both the methods. Very good. Let's now also see whether the static variable has a default value or not. Let's save it and see whether it contains a default value or not. So yes, it also contains the default value 0 and 0. So static variables are acting similar to the instance variable. Like instance variable can travel in any function except the static. Static variables can travel into any functions, whether it is static or non-static. So let us try and create a static function now and test whether static variables can be called within the static function or not. So as they already have a default value, I'll just be giving a value to it, that is 88. Now let's go ahead and create a static or I'll just mark this function ABC as static void ABC, and because I'm creating it as static, so I will not be able to call a non-static function here, sorry, non-static variable here. So I'll just comment that, and static variable is being called in a static function. So let's run this. And also one important point here, see, for static functions we do not need any object reference, right? I don't need an object reference to call the static variables, but even if I give the object reference, it gives me a warning, it does not give me an error. Okay, so it is recommended not to use an object reference with the static functions, but if you use it, it is going to give you a warning but not an error. So always remember that static functions should be called without an object reference, because static functions are something that exists before object, and calling it with the object reference makes no sense at all. So let me just remove that as a good programming practice. Even if I don't remove it, my program will still run fine. Okay, so let's save it and run this. So now you can see that 88 is being called in a display function, as well as it is being called in ABC functions. So static variables are independent, they can travel anywhere. They can be present into a non-static function, or it can be present into a static function as well, because they are independent, they are created before object, so they do not depend on the object for their existence. Even if you want to call it right inside your main method, you can directly call that variable here. So if I just say system.out.println and I call this as main plus the static var, that will also be a valid way of invoking static function, a static variable, because main is also a static method and static methods can access static variables directly. Okay, so let me put this example also into the repository and we will talk more about again the static and the non-static variable, which is nothing but what? Class variables and the instance variables. Okay, this is our demo for static versus instance. So it can be called as class versus instance. So static variables are nothing but the class variables. Okay, sorry, I'll put this code, commit the changes. There we go. All right. So here now I will first of all clean up everything and again compare the behavior of static and non-static. The reason why I always clear things up is to revise you about the things, because that will be it'll be a good idea to revise the things, right? And also it will be a clean code so that people who are concerned about uh, um, the length of the code will also find it easy for the understanding. So here I have a local variables we discussed about, instance and class variables we have discussed about. Let us discuss more thing about this static variable, and also as I discussed in the video previously about static having its own memory. So let us now create a variable. Let's say int inst is equal to, I'll not give any value to this, and also I will create a static int stat as a variable name and I don't give the value to it, and I will directly call both of those variables. So both the variables should contain 0 because it's an integer variables have the default value as 0 if they are instance or static. So when I try to call this static variable, it will be called fine. There will not be any issue calling it. So when I call this, there is no problem calling the static variable, but when I try to call the instance variable, I have the problem calling it. Okay, so you can see that. So whenever I am trying to call this instance variable, I am getting an error, right? So instance variables cannot be called directly like this. Now what is the reason? Again we are comparing static versus instance variable, so this is going to give us an error. How do we resolve that error? To resolve that error, we need an object reference. So object references are required for what? Object references are required for memory. Anytime we are creating an object, it means that we are allocating memory. So the best way of creating an object, class name again, then the object name should be same as class name, starting with the small case character. So object is created. So object reference, use the instance and then call the instant variable, and that will be fine. So whenever we are calling the instance variables, it requires an object reference. It cannot be called directly. It can only be called directly within the non-static functions, but in static function it requires an object reference. So if I write it like this, it will be completely valid and both the variables will be 0 since the default value is 0. I did not initialize anything. So but the issue is that for calling an instance variable, we require the instance. That means an object reference is required, and for calling static variables, instance is not required. So this proves you that static variables appear to exist even before creation of an object, whereas instance variable depends on object for its existence. The life of a static variable appears to exist as long as the class is loaded in the memory, whereas the life of this instance variable appears to exist till this object reference has memory. So if I mark this memory as null, I would get null pointer exception if I try to access that variable. What do I mean by that? That means if the memory is released from this object, we will not be able to see the result of instance variable. So let me just do that over here and show you what exactly I mean. So when I say demo1 equals to null, that means now I am initializing a null memory. So memory whatever was allocated to this object is gone now. So whenever we are referring null objects, at that time we are going to obviously get null pointer exception. It means that the memory allocated to this object is gone now and we are trying to access instant variable, instance variable on this memory which is null. And whenever we try to access null objects, or sorry, whenever we try to access variables or functions on a null object, at that time we are going to get a null pointer exception. So you can see that we are getting a null pointer exception, indicating that the memory allocated to the object is gone, and you will be getting a null pointer exception. Okay, null pointer. Why is that? Memory is deallocated. But if I go in detail, I cannot still say that the memory is deallocated to this. Only thing is that I am pointing this demo1, this reference variable is now pointing to a null memory. In Java, we know that there is something called as a garbage collector which runs automatically and cleans up the memory. Okay, and to call the garbage collector, we can make use of the system.gc or runtime.gc. We will not go in detail on that as for now. Just remember that whenever you are creating instance variable or static variable, instance variable, as their name suggests, that they require the instance of a class. That means they require an object. So their life depends on the instance of a class. That is why it has to be always referred with the instance in a static function. If it is a static variable, static variables can travel anywhere because they exist even before creation of an object. You can access it anywhere, be it a non-static function or a static function. Now if I create a non-static function like test and then try to call both these variables, there will not be any problem calling them. So you can see that here in this line, which was giving us error before, it will not give us error here. That's because test can only be called after the object creation. So here also instance variable is dependent on the object. So because even test is dependent on the object, so what it does is that when you are calling test, you have to create an object and call it. So because of which it is completely valid to call a instance variable here without creating the object reference. Okay, so that's how static and non-static variables behave. So let me once again copy this code and put it into the repository for your reference. So this is our demo 5. Once again, it is about the class variable versus instance variable. Okay, static variables are called as class variables because they appear to exist as long as the class exists. An instance variable, their life depends on the instance and they appear to exist as long as the instance, that is the object of the class, exists. And the moment you create the instance, you get the fresh copy of instance variable. Now what do I mean by this statement? Whenever I create a instance, I get a fresh copy of instance variable. So let us just explore that and see how things work. So now once again, I will just clean up everything that I have written to focus on that statement which I have made, that is instance variable maintain a separate copy or exist the moment we create an instance, there is a new copy of the instance variable. Let us explore that statement. So what I'm gonna do is I will be creating an instance variable. Let's once again call it as int. Any variable that is not marked as static and it is outside the method is an instance variable itself, right? So int, let's give some name. Let's call this as int test instance variable is equal to, let's give it as 10 here. So I'm trying to create a variable, declare it and initialize it there. Similarly, I will create a static variable also. So let's create a static variable in the sense a class variable itself. So static int, let's call it as stat var. Okay, let's call this as instance variable and that as a static variable so that we can compare it easily. Now for this I'm giving the value as 100. Now what I will do is I will try to create two objects of the class. So let's see how do we do that. Once again, it's the same procedure that we are following. Demo1 is equal to new demo1. One object of the class is created, and the moment the object is created, instance variables comes into picture. Instance variables will come into picture only after creating the object. It will not be in picture until and unless it is created. But static variables, they appear to exist even before creation of object. I can execute a static variable even before the object, but I cannot execute the instance variable before this, right? So even if I try to do that, I'll get an error. You can see that. If I try to do this, I'll get an error. Even if I try to do something like demo1 dot instance variable, I'll still get an error. That is because demo1 is declared here, cannot be accessed here. So Java follows a top to bottom approach. There are some programming where you can do this. Okay, so that's interesting. One such thing can happen in JavaScript. So we'll see that in our later sessions. So this cannot be done. That will be an error. So same thing, if I write the line here, it will be completely valid. So now I'm just testing. I created a static variable, created an instance variable, called the static variable without an object reference, and now calling an instance variable with the object reference. So let me run this and call this. Okay, 110 is being called. Now what I will do is here inside this main method, I will be creating one more object for the class demo1, and I call the instance as demo2, and I'll call it as d2.instance variable. So object of the same class is created. Let me save it and call the variable now. So now three results should be displayed to me. One is for static variable, first one. Second one is for the instance variable of demo1, and again the demo2. So I run this, all of them. Obviously static variable is declared as 100, so it is being printed as 100. Instance variable is 10. Now, as I told you about the statement, the moment you create objects, they give life to the instance variable, and every object contains a separate copy of the instance variable. Now, what do I mean by having a separate copy of the instance variable? So let us test that now. So if now I create demo1 dot instance variable, I will mark this as 500. Okay, so the value of the variable is now changed to 500. Which variable's value is changed to 500? Instance variable, right? So when I give it as 500, I'm trying to print that variable here and the same variable here, but with a different object reference. So let's save it and see whether the value of this instance variable is changed in both the situations or both these scenarios or not. So when I run this, you will notice that only demo1 dot instance variable is changed to 500. The other variable remains the same because there are two separate memories for these two. That is why the two separate results are printed for these two variables. Whereas if I change anything to the static variable, for example, here I will print the static variables twice. Okay, static variable does not require any object reference for their execution, right? So time being, I'll just remove this comment. So twice I'm printing this static variable, and what I'm gonna do is static variable is declared as 100 here. That will be printed as 100 here. I will change the static variable like stat var is equal to 800, and by this time it was 100. Now it has become 800. So this should print me 800. Once again I will print that. So it has to print me 800 itself because that variable's value is changed, right? So let's save it and run. And by this example you might say, okay, this is similar to what is happening in demo1, right? So 100, 800, 800. Now what I will do is, we can call the static variables even with the object reference, but that is not a good practice. But just to make you understand that static variables maintain the same copy for all the instances, I'm doing that. So let's go ahead and say demo1 dot static variable is equal to 700. Okay, and we'll call the static variable on demo1 and demo2. So let's call that on demo1 and demo2. Demo1 dot static var, although writing this is not recommended, but still what we are testing is whether the static and non-static variables, static and instance variable, they maintain separate copy or same copy is what we are testing. So it's exactly the same. I have changed the value of the instance variable to 500. I've changed the value of the static variable to 700. So instance variable before was 100. So let me just comment this out, which is definitely print 100 to us. Okay, so we have just two variable, instance and the static variable. Here in the demo one object, what I'm creating is I'm giving a different value to instance variable and changing the value of a static variable. Here also I'm here in the second object I'm just calling them both. Okay, so let's save it and see the result. And obviously if it contains the same copy, the value has to be the same. If it maintains the separate copy, the value has to be different. Let us just see this graphically, what is exactly happening in this code. So when I go here, so what I have declared in my program is I have created something like static int. So let's just increase the size of it so that you can see it bold. Okay, so what I have done is I'll be creating something like static in my program. I have created static int stat var, and I marked some value to it. So let's just take the same example, that is 100, and I created a int instance variable is equal to 10 is what I have given. So when I print these two values right now, I will get the static variable as 100 and instance variable as 10. So what I am saying is, static variable, any time you create an object, this instance variable comes into picture, but for now static variable is already there. So memory of static variable is created, name is given to that memory as static variable, static var, and the value that it contains is 100 here. But this instance variable will not come into picture if you write only these two lines. Instance variable will come into picture only after you write this particular line here. What is that? So the moment you create the object, you get the instance variable. The moment I write this line now, I will be getting the object instance variable. So now an instance variable is created. Name of that instance variable is inst var. Okay, inst var is created, and the value is initialized to 10. If no value is given, by default it is going to be a 0 because it is of type integer. Now this object, this variable is created only for this particular reference. Next time when you write this line again, that is demo 1, demo 2 is equal to new demo 1. That means if you are creating another object of the same class, what is exactly happening is that it is actually creating one more memory block for you, and it is initializing that 10 here. Okay, so what happens here is, again a 10 is initialized, and this will be named as inst variable itself, inst var. So now they both are 10. So if suppose I do not change the value of these two variables, let's say if I don't give it as 500, let's not even give it as 700, let's now test it. So if we test it now, you can see in the boxes it is 100, 10 and 10. So that is what I'm expecting here, right? So the first value I did not give, I did not change any value. So let's save it and run this and see the result. So I'm getting the value as 100 and 10 and 10. All of that is fair enough, right? So instance variables value I'm getting, static variables value I'm getting. So as for now, I'll not print the static variable twice. Let's just be like this. So it should print me a value of the static variable 100. Then this should print me 10 for this and 10 for this. Let's save it and run this. So it's giving me 100, 10 and 10, perfectly fine. So what we have imagined is okay. That means whatever we are imagining is perfectly logical. Now what I am doing is, in the next lines of code, I am trying to change this static variable's value as 700. So the moment I change the value of the static variable as 700, and then I print that static variable for demo 1 or for demo 2. Okay, demo 1 I'll be printing the value of the static variable, and for demo 2 also I'll be printing the value of that static variable. Now when I save it, although it is not recommended to be called on the object reference because static exists before object. So what happens now? There is only one memory copy of the static variable. So the first value will be gone, updated value will be given, that is 700. So what is the value now? The value is 700 irrespective whether you are referring it with demo 1 or demo 2. In fact, static is independent, so it does not require any object reference for its existence. So now the updated value is 700. So let's go ahead, save it and see whether the updated value 700 for both the objects will be printed to us or not. So when I run this, you can see for demo 1 and for demo 2, for both it is 700. So just for understanding, I'll add it as demo 1 plus the value of it, and for demo 2 plus the value of it. Okay, static variable for both demo 1 and demo 2 has become 700 if I just change it for one instance. Okay, so only demo 1's value is changed, but still for demo 1 and demo 2 it is changed. This for demo 2, this is for demo 1. Okay, the values are changed now. That is because static maintains the same copy across all the instances. Similar thing I will do. Static maintains the same copy for all the objects that I am creating, but instance variable maintain the separate copy. So I'll change the value for demo 1. So let's go here and change the value for demo 1 instance variable now. So demo 1 I'm marking it as 500. Okay, so this is for demo 1 again, instance variable for demo 1. Let's call it as d1 or demo 1 is fine, and this is for demo 2. Instance variable, right? So the other one is the static variable and the first one is the instance variable. Now when I'm writing this instance variable here, the value is changed to 500. Value of 500 is changed for demo 1. So what happens is, there is this demo 1 instance variable, value 10 is gone, updated value is here now. So the updated value is 500, so we should get 500 for this. Now this is how that memory looks like. If I refer this instance variable with demo 1, we get 500. If I refer the instance variable with demo 2, we still get 10 because they maintain separate copy. If they maintain the same copy like static variable, we would have got 700 for both. Now that we should get 510 if it maintains separate copy. If it gives us the same result for both, then it maintains the same copy. So let's save it and see the result. So now when I run this, my focus is on the instance variable. So for demo 1, the instance variable has become 500, but for demo 2, instance variable is still 10, which basically means that instance variable maintains the separate copy for the variables, whereas static variable maintains the same copy for all the instances. So any time you are creating an object, you get a separate copy of instance variable, same copy of the static variable. Okay, so that's the conclusion. So I'll put this particular code again into the repository. Another difference between the instance and the class variables: class variable maintains the same copy, whereas instance variable maintain the separate copy. So this is our demo 6. Class variable versus instance variable. All right, I hope that you're getting the points which I am trying to explain in this videos. Obviously it's being a bit lengthy because we are focusing on every single details of about the videos. So definitely it is going to be quite lengthy. The series is going to be lengthy, and to be very frank with you, the videos, the tutorials that you see, learn Java in 10 hours or learn Java in 5 hours or learn Java in 10 minutes or learn Java in half an hour and all, they are all myth. You cannot do that. So for learning Java full stack, you need some time and you need to spend quality time on it, because it has a lot of things into it. So if you give me the time, I'll make you understand the concept of Java full stack, and I hope my videos are easy for you to understand. So do comment on this particular video. If you like this video, do share it with your friends, subscribe to my channel to get more such videos and encourage me create such beautiful content for you. And see you again in the next video, where again we will talk more about the type of data types that are available in Java. Here we talked about the type of variables available in Java, so we will talk about the data types in Java, how memory is allocated to those variables, why do we have different type of variables and all that. So till then, take care, have a nice day.